Learning intentions for today, we're going to talk about the chain rule. The chain rule allows us to look at more complicated functions, specifically composite functions. That's where there's more than one thing going on. If you need to pause the video now to write down some terms and notation, feel free to do that. So we've studied composite functions before. That's like where you have an f of x and a g of x, and you take f of g of x, where you're doing one thing and then putting that into another equation. And a chain rule is a way to find the derivative of those composite functions. The way the formula packet shows it is if you've got y equals a function of another function, so I'm calling this f of u, and u equals this function u of x, then the derivative of y in terms of x is equal to the derivative of y in terms of u times the derivative of u in terms of x. It sounds a little more complicated than it needs to be. So another way to say it is you do the derivative of the big picture, leaving the u inside, multiplied times the derivative of the u. I say it a different way. I say if you've got a big picture going on where there's some stuff inside of there, the u, you do the derivative of the big picture times the derivative of the stuff that was inside of the big picture. I've summed this up with some steps here. Again, if you need to pause the video to look at these, it's fine. Is it a composite function? If so, what is the f of x, the big picture? What's happening? Are we squaring? Are we doing a radical? Something like that. We need to know, is there a big picture that's going on, something we're doing to the entire equation? Let all of the other stuff that's inside of that radical or inside of that set of parentheses or whatever be represented by u. You can actually replace all that stuff with the u in the function. Find the derivative of that big picture, f of u, where you've replaced all the stuff, and then do the derivative of just the stuff as well. Put the stuff back in there, and then multiply by the derivative of the stuff, or the u. You'll hear me saying stuff a lot throughout this lesson. This might seem a little bit confusing right now, but hopefully I can clarify that a little bit on the next slide. Nice big font for you here. Example 1. We're given a function y equals the quantity x squared minus 7x to the 4th power. What are the composite functions? And then find the derivative of y in terms of x. We should probably go through this one together first. So big picture, you've got some stuff. You got x squared minus 7x. That's like our u. That's the stuff inside of the big picture. So u is equal to x squared minus 7x. Well, what's the big picture? All that stuff is being raised to the 4th power. So we sort of have like u to the 4th power. U is all this stuff, and all that stuff is being raised to the 4th power. So those are our composite functions. Now, what we can do is we can take the derivative of u to the 4th, which becomes 4u to the 3rd, and we need to multiply it by the derivative of the u. And that was squared there, so that becomes 2x minus 7. We're multiplying these two things together. Except I don't want to have u's in my final answer, so I need to go back, put my stuff back in here. So I have 4 times x squared minus 7x, all my stuff, times 2x minus 7. You could probably leave it like that since it's pretty well factored. The back of the book might vary from time to time. IB will often do a show that problem so that you get it in the same form they did. If you wanted to maybe distribute the 4 over here, that would be fine, and so you could have x squared minus 7x times 8x minus 28. Something like that, but we were probably fine right here. So let me do that one more way, and I won't write down any u's. you've got some stuff to the fourth power. The chain rule says do the derivative of the big picture times the derivative of the stuff. So the big picture, you got stuff to the fourth power, you bring the 4 out in front, keep all your stuff in there, and then you lower the exponent by 1. So you have 4 times the stuff to the third power, but you have to also do the derivative of the stuff, which is 2x minus 7, and that's the chain rule right there. Again, if it helps to write out the part, say, okay, what is my stuff that's going on here? Write that down, write out what u is, find out what u prime is, but eventually you want to get to the point where you can look at that problem and do it as quickly as I just did there. Let's try it out on the next example. So, y is equal to the square root of the quantity x cubed plus 2x squared minus 3x plus 17. We want to find the derivative of y in terms of x. Let's take a few minutes for this. Again, figure out what your stuff is, what your big picture is. If you need to label u and find the derivative of u, that's fine. If you can do it all in one step, I'm impressed, and you can give that a try. You can pause the video now. All right, let's take a look at this one. So obviously our big picture is we've got a big square root going on. And so all of this stuff here, we can label u. U is equal to x cubed plus 2x squared minus 3x plus 17. We're eventually going to have to take the derivative of that stuff. So we may as well do that now. 3x squared plus 4x minus 3. And then what's our big picture? Well, the big picture is we've got a radical going on. And so it's like the square root of u. And we probably want to write that as u to the 1/2 power. Any radical can be written that way. So what's the derivative of u to the 1/2 power? Well, you bring the exponent out in front, so you have 1/2 times u, and then we lower the exponent by 1. So, to the negative 1/2 power. And all of that is then going to get multiplied by the derivative of u. Well, the derivative of u is 3x squared plus 4x minus 3. But we don't actually want any u's in our problem, so we need to substitute back in all of the u. So I'm going to move my work over here. So I've got 1/2 times all of the u, which is x cubed plus 2x squared minus 3x plus 17, all to the negative 1/2 power, times the quantity 3x squared plus 4x minus 3. Now, we don't like leaving negative exponents here. So, what does the negative exponent tells us? It tells us everything's in the denominator. We already have a 2 in a denominator, so we can bring all this stuff down, and the 1/2 tells us that it's a radical. So I'm going to have a big old fraction bar. In the denominator is the 2. All of this stuff is down there as well because it had a negative exponent, and it's all inside that radical because it was to the 1/2. So we have x cubed plus 2x squared minus 3x plus 17. And then this stuff goes up to the numerator times the 1, but the 1 doesn't change it, so we have 3x squared plus 4x minus 3. And that right there, ladies and gentlemen, is the chain rule. Alright, here's another example for you. Y equals 6 divided by the quantity square root of 3 minus 4x. We want to find the derivative. Let's take about 5 or 6 minutes here. You can pause the video now. Alright, let's take a look at this one. So, what is the big picture? This one's a little bit trickier. Obviously, I see some stuff. We've got u is equal to 3 minus 4x. u prime, make that x a little better, u prime, constants go away, and then we have just negative 4, I believe. All right, and so we could rewrite this then as 6 over the square root of u. Well, what's a better way to write that? We can write that as 6 times u to the negative 1/2 power. The square root makes it 1/2, and the negative is what puts it in the denominator there, so 6 times u to the negative 1/2 power. We want to now find the derivative of that. So the derivative of, sorry, got my prime symbol there. The derivative of 6u to the negative 1/2 power is going to be negative 3u to the negative 3/2 power. And then we have to do the chain rule, which multiplies the derivative of all that stuff, which I left a lot of space there, but it's just negative 4. Actually, let me clean that up. Okay, but we don't want to leave u's in our answer, so we need to substitute back what we had in the first place. So we can write this as negative 3 times whatever u was, which is 3 minus 4x, to the negative 3/2 power, all times negative 4. Well, you might notice I've got a negative 4 and a negative 3. Why don't we just multiply those and make it 12? So I've got 12 times 3 minus 4x to the negative 3/2 power. Negative means it's going in the denominator, so I'm going to have 12 over 3 minus 4x quantity cubed, and then there's a 2 there, so we can square root the whole thing. So that's a 3 here. So I have 12 divided by the square root of 3 minus 4x quantity cubed. Chain rule. All right, this one has us combine what we did last class with what we're doing today. So we're going to need to, luckily, not write an equation, but actually find the slope of the tangent when x equals 1. So we're just finding slope, but in order to get slope, we need to have derivative. So let's take about 5 or 6 minutes to do this one. You can pause the video now. All right, let's take a look at this one. This is one that you can probably do without showing work once again. We've got u is equal to x plus 1 over x. That stuff right there. The derivative of that is actually a little bit tricky because we've got, this could basically be written as, x to the negative 1 power. So we have x plus x to the negative 1. The derivative of x is just going to be 1, and the derivative of x to the negative 1 is going to be negative x to the negative 2. We can rewrite that as 1 minus 1 over x squared. But we still need to deal with the big picture. The big picture is we've got u to the 3rd power. So we do the derivative of that. 3 out in front, and then we've got squared times all of the u prime, which is 1 minus 1 over x squared. We don't want to have u's in our final answer, so we bring back our original problem, which was 3 times x plus 1 over x, and then we've got 1 minus 1 over x squared. You might be able to do something here to clean this up or distribute, but there's really no point. All we need to do is find the slope when we have x equals 1. So I'm going to start plugging in some 1's. So I've got 3 times 1 plus 1 over 1, also known as 1, times 1 minus 1 over 1 squared, also known as 1. So 1 minus 1 is 0. 0 times anything is 0, and so we have a slope of 0. For homework, page 366, number 1 to 4.